Hello, my name is Salvador St. Louis, and today I'm going to be covering silicon carbide fiber reinforced titanium matrix composites, often shortened to SICTI composites. These are advanced materials designed for extreme environments, and the goal is to combine strength with a low weight and with heat resistance all in one sort of super material. Today in this presentation, I'll be explaining what they are, how they're made, and what their uses are. What is a silicon carbide fiber titanium matrix composite? Well, it is a specially manufactured composite, which is a combination of two different materials. The silicon carbide fibers act as reinforcement to the material, and the titanium is used as the sort of body and glue for the new material. The fibers add strength and reinforce the material post-production, acting as a sort of backbone for the already durable and resilient titanium. Special traits and strengths. Silicon carbide fiber reinforced titanium is extremely strong and lightweight, netting a higher stiffness and resilience compared to just regular titanium. Silicon carbide fibers are ceramic-based, so they're resilient to high temperatures as well, which is crucial for the manufacturing process, as well as their primary application in engineering. Since it's so solid, heat-resistant, and lightweight, it has notable use in aviation and aerospace engineering, like I just said. Manufacturing. Now, the steps to manufacture this material are not very complicated, but each one of them is extremely precise and has a lot of impact on the quality of the final product. And every bit of quality matters in this material. The manufacturing begins with aligning your silicon carbide fibers with the needs of the finished project. So wherever they need to be stronger, that's where you line most of them up, but you want to have them in a definite and set structure. Next, they either layer thin sheets of titanium foil or powder and stack them into whatever shape they want the product to be. Once these layers are arranged, they must be bonded through a process like hot isostatic pressing or diffusion bonding. And these are processes that specialize in putting the material under very high heat and stress to the point to where it softens that titanium and lets it flow around the silicon carbide fibers and bond with them without melting the fibers inside due to the titanium having a higher heat resistance. Once the composite is bonded and solidified, it must be shaped and machined, which is often extremely difficult due to its high resistances to stress, heat, and other things. Finally, once they've made the material, they must evaluate it on the quality of the product and look for defects. And they do that by using X-rays and ultrasonic testing, since you can't just crack it open to see what it looks like on the inside. But they have to do these sort of testing so that way even small defects are caught, because small defects can end up being extremely disastrous for this material and end up ruining the entire piece. Applications. One of the main uses for silicon carbide fiber titanium matrix composites is in the field of aerospace engineering. Things like jet engine parts and spacecraft parts are often made from this material, and that is because these parts are meant to operate under extremely high heat, pressure, and rotational forces, so they benefit greatly from the higher strength and lighter weight that this material can offer. While this may be a strong and amazing material, it does have some very real and noteworthy limitations that prevent it from being used more in other fields. Limitations and weaknesses. The main limitation this material has is its cost. The raw materials alone are a lot more expensive than other materials, and the processes to make this material, this composite, requires specialized equipment, high temperatures, and very controlled production conditions, all of which cost a lot of time and money and resources to even have before you can make the material. Another weakness it has is its difficulty to repair. Machining and repairing the material is very difficult due to how resistant it is to wear and tear and things like heat, as mentioned before. Because of its cost and somewhat difficulty to produce and repair, it's mostly been limited to aerospace engineering, like with jet engines, spacecrafts, and some defense systems have been seeing use too. Overall, this material is best suited for when performance is valued over cost. In conclusion, silicon carbide fiber reinforced titanium matrix composites are an excellent example of how combining materials can dramatically improve their performance. By reinforcing titanium with silicon carbide fibers, engineers create materials that are lightweight, strong, and capable of surviving extreme temperatures. Although they are expensive and difficult to manufacture, their advantages make them essential in aerospace and other advanced engineering fields, although they have seen limited use in fields outside of that. As technology continues to improve, materials like this will surely become more important and common in the future. This is my works cited page. I'm going to leave it here for a few seconds.